Hello and welcome to this video exploring the scientific evidence for or against cold water immersion as a post-exercise recovery tool. Expect to learn how cold water immersion stacks up against passive recovery, i.e. doing nothing, when it comes to managing or minimizing delayed onset muscle soreness, perceived exertion, and 3 biomarkers of muscular fatigue. To do this, we'll explore a recent systematic review and meta-analysis research paper that analysed 20 studies on exactly that. Let's begin. First, let's look at who they've included in the study. Human subjects. Nice, our favourite kind of subjects. They've also included only randomised controlled trials and crossover design trials. So the researchers have avoided using too many bottom-of-the-barrel, low-quality sources of evidence. In the randomised control trials, they've pitted people who've taken a cold plunge to those who have sat there and done nothing. And in the crossover studies, they've used the same people trialling at different times, either cold plunging or not cold plunging. They've gone on to use a temperature cutoff at 15 degrees Celsius, which is 59 degrees Fahrenheit, which is not too shockingly cold and a long way short of being a true ice bath, but it's still a fair bit colder than most of us normies would like to take a bath or shower. And the 20 studies that were sufficiently rigorous to fit the researchers' criteria included a total of around 400 adults. So not an enormous data set to be playing with, but not nothing either. But before we get on to the rest of it, they've got a little chart on the risk of bias in each of the papers, with a plus sign being a low risk of bias. So we've got 2 papers that have sailed through there, a negative sign or the dash being unclear, and an X being a high risk of bias. So there are some risks of biases in quite a lot of the papers, as you can see. And here's the risk of bias breakdown into which forms of bias are most likely: allocation concealment selection bias and random sequence generation selection bias. Then we've got a table on the protocols followed in each of the studies. You can see that the exercise protocol varies from 5K runs to swimming sprints to resistance training, intermittent fartlek style stuff, plyometrics, and not a lot of resistance training there overall, to be honest. It's also got a breakdown of the time spent immersed in cold water, but for some reason the table isn't playing ball. It tends to be around to that sort of 15-minute mark mostly. Now let's get on to how everyone fared. The first marker of fatigue was an objective one called counter movement jump, which is where you squat down and then jump up as high as you can. But first, a brief, massively oversimplified aside on how to interpret these forest plots that you find in this sort of data. The vertical line represents no change or benefit using cold water immersion versus not. All the horizontal lines and the dots within them represent the data in each of the trials, which each get 1 line. If the dot and its line or whiskers lies entirely to one side or the other, then we have a statistically significant, which is to say 95% probability of not being due to random chance effect, either in favour of cold water to our left or against cold water to the right. And the diamonds are an amalgamation of all of the subtotal data from the studies above, and the diamond at the bottom is an amalgamation of all the data provided. As we can see for this counter movement jump, there is a slight benefit found when you're jumping immediately after your exercise in cold water, a slight detriment found when you're jumping 24 hours afterwards, no statistically significant effect at 48 hours, and no statistically significant effect overall. A further point on the width of the whiskers is that if you have a big data set and lots of people involved in your study, you tend to have what's called a powerful study, and you get these narrow whiskers. Here, as always, big data, more data is better. And the last point to make on how to interpret forest plots is that the effect size is illustrated by how far our point, our whiskers, and our diamonds are from the midline. A diamond that sits very close to the midline represents a small effect size, and one that's much further away, a much larger effect size. Let's get on to the big stuff, DOMs. This is a necessary evil for most of us that it would be nice to cut down on so that we can train hard enough to stimulate hypertrophy and maintain something resembling a normal life the rest of the time. So let's have a look. We've got diamonds to the left of the line, both immediately after exercise in cold water and at 24 hours, and it looks like it's probably just about touching at 48 hours, but we get an overall statistically significant but small effect to the upside, favouring cold water immersion over not doing it. And this is RPE, or rated perceived exertion, and it's essentially asking people to subjectively describe how fatigued they feel. And again, we have similar number of studies, maybe slightly fewer overall, particularly over the longer time frames. And not many of the studies individually come up with statistically significant difference, but we do have an immediate statistically significant difference. And that seems to sort of drag everything slightly over to the left, meaning that overall we have a statistically significant difference in favour of cold water immersion for your perceived exertion. Next, moving on to the biomarkers, which are substances found in a blood draw that tend to increase with muscle fatigue and muscle injury. The first of these is creatine kinase. This is an enzyme involved in the phosphocreatine system, and as that's almost totally bound up in skeletal muscle, this is a good proxy for muscle damage. Here we've got as many as 12 studies included, so that's pretty good in terms of the relative availability of research. But we can see that we have diamonds not shifting far from the midline and lots of individual studies right bang on the midline. So overall, we've got no statistically significant difference for creatine kinase, but we do have a small statistically significant difference at 24 hours only. And next, lactate, which is a product of anaerobic respiration. Here we go. We've got it slap bang in the middle at immediate, and we've got it to the favouring cold water immersion at 24 and 48 hours, giving an overall slight favouring of getting better lactate scores on the bloods when you've dipped yourself in cold water for 15 minutes. Next, CRP, or C-reactive protein. As the name suggests, C-reactive protein tends to react to almost anything, including but not limited to physical exercise, essentially any pro-inflammatory state in the body. Straight down the middle, no effect. And finally, interleukin-6, which is a protein involved in the immune response driving inflammation, but as the authors themselves have acknowledged, there's insufficient data to render the results anything other than meaningless. We've only got one study here, one there, and they all run straight down the middle. So let's keep going. Let's see if they've disclosed any conflicts of interest. Great, so they've not declared any conflicts of interest. Big Ice not winning here. Okay, so let's quickly recap the evidence from this particular meta-analysis into post-training cold water immersion. The science suggests a statistically significant but small benefit to the subjective experiences of DOMS and perceived exertion, especially immediately post-training, but it is much murkier and more limited a picture when it comes to objective measures, with no overall benefit to counter-movement jump performance, though oddly it seems to benefit immediately afterwards and then become a hindrance, and no overall effect on creatine kinase or CRP, too little data to waste our breath discussing interleukin-6, but a small benefit to cold water immersion when it comes to lactate levels. As for what this means in the real world, it seems that this science backs up the claims that cold water immersion can make you feel better after a workout, so if you enjoy it or think that you could enjoy it and want to feel more well recovered sooner after training, then crack on. And it might simply be a case of we're looking at the wrong biomarkers, or that it is simply just a case of feeling better without actually making us better recovered on a cellular level. If you've enjoyed the video, please consider liking and subscribing to the channel. Goodbye.